All right, so we are live. Hello, everybody. Today I'm going to go through my talk that I gave at GOTO Chicago. I'm going to go into a little bit more detail and then kind of go quicker through some other parts, just so we can have time for discussion around the fun parts of this. If anybody's watching, feel free to use the questions app. Other people can monitor that because I'll be sharing my screen and full screening my presentation, so I won't be able to see if anybody's asking questions. But anybody here at Bitovi has any questions, just stop me at any time to ask any questions you have. So with that, I'm going to share my screen and get this party started. So I'm just going to use my my talk as a blueprint for what I'm talking about here. So let me just get to the beginning of that. So what Matthew and David and I have been doing is building this placemyorder.com application, even though I think people have the domain, which is place-my-order.com. You can see this app, but I think it is broken right now, the deployment. But what this app is it's a lot of awesome, it's a very simple app that has a lot of complex and I think pretty cool parts. It's server-side rendered, it's a progressively loaded, but it's a progressively loaded single-page application. It uses push state, it has a real-time connection, it has fall-through caching, and a lot of other fun features. So what we try to do is pack everything cool and modern we possibly could in a single application. And you can see this application at Bitovi Place My Order. And there's some instructions on it, and install it, get it running in production, and that kind of thing. So just a quick, I'm going to go through the features of this application, or just the actual functionality. So there's a home page. You can see it very, as the progressive loading is happening, you can see it very well. You can't see it once it's all cached, but you saw a very brief little loading where it'd say it's loading. I can pick a state and then pick a city. Pick a city, then get more information about a restaurant, then order from the restaurant, and then this lets me pick some items and order something. Place my order, and then once I place my order, once I place my order, I can see all the different order statuses and mark and move my order through different statuses. So now it's out for delivery, now I'm marking it as delivered, and then eventually you can delete it. So that's the functionality. I'm going to go through now how it's built. So someone in glasses. Let me hide this. There you go. Okay, so the first thing that this is done with is it uses the Modlet workflow that hopefully everybody here at Bitovi is really familiar with. The Modlet workflow basically means instead of organizing your project like this, where things are broken up by the type of resource. So I have all my JavaScript files in one folder, all my tests in another folder. Instead, at Bitovi, we pretty much always try to organize things like this, where every module has its own folder, and all the resources for this folder, or for that module, are in this folder. And a lot of times we also include a test page that runs just that module's tests, and a demo page that runs just that demonstrates the behavior of this module, especially if this module is a like has a graphical representation. It's like a widget. So I'm not going to really go through the benefits of this. I think we all know, at least at Bitovi, why we do it this way. The big reason is because you can see, you know, I think it's because the tests essentially are staring you in the face. You know, this order folder has, if I'm working on this order module, closer makes me feel like I'm more likely to edit the test. Also, I can run in isolation. I can open up that. I can open up that orders demo page and make sure my functionality is working all in here, and I can make sure its tests all run without having to run or even load all the other tests to make sure this is working. Okay. The next thing this app does is it uses semantically versioned packages. As you might have seen, there's this restaurants. When you're ordering from a restaurant, this tabs widget is loaded. It was built independently on its own. You guys are, I think, all familiar with bit tabs. So instead of building this tabs widget kind of locked inside the bigger Place My Order application, we extracted all of its source and we put it in bit tabs and used bit tabs, and we created bit tabs as its own project, and we can import that via npm into the Place My Order application. What it looks like is pretty simple. This is in the order stash. I just have bit tabs, and I provide the panel for the lunch menu and the panel for the dinner menu. So hopefully you guys have all seen this, and hopefully you all know the process. I think we've done a really good job. Now Matthew especially has done a really good job of making the process for being able to extract out your own component and build it into its own project relatively easy. I think the Bitovi components team has also kind of shown that since Austin. But you know, in general, the idea is that you just npm install, and nowadays anything that we build like bit tabs, you should just be able to npm install and automatically use in your project. So in my presentation, I kind of walked through what this looks like a little bit more than I'm going to here, because you guys have all seen this, hopefully. Again, stop me if you guys have questions. So what I think the benefits of this will be, and I really want to encourage everybody at Bitovi to start doing this process. Whoops, I'm in the wrong folder here, or the wrong slide. I think the benefits for pulling everything out into their own projects and then importing them, I think a lot of the benefits are obvious, especially around reuse, right? If we can start doing this on a lot of our client projects, it'll be easier for us, you know, with the approval of our clients, it'll be easier for us to build other applications in the future, because importing that functionality is so straightforward. But I think another benefit that will happen is because we can use we'll be publishing these modules to npm, and therefore adding semantic versioning to them. I think that's a lot of meta information that gets lost when you're building things inside of a bigger project. So if I was working on bit tabs inside Place My Order, and I added a new feature to it, if you are the consumer of that tabs widget, you have no idea, like, if I've added a new feature, if I've broken its API, any of that kind of stuff. With semantic versioning, at least we're adding a little bit of that metadata to make these kind of things, like to kind of better inform the people who are using our modules the expected changes between different versions. The next thing I think we can do with this technology is for something like you know, a project where you've got a lot of different pages. I think you could actually build those pages as different projects, and it would make release management a lot easier because you would be able to point at different versions of different pages, and if one is breaking, you can roll that back a lot easier than a branch and merge strategy with GitHub would allow. And then finally, you know, the big goal for StealJS has been making it possible to do client-side open source a lot easier, because I think a big problem with client-side open source as it exists right now is how hard it is to make a project that depends on some other projects, but then still export your project so it can be useful to all the common module formats. So I think what StealJS is really trying to solve is this problem. It would be really nice if the client-side ecosystem of open source could be as rich as Node or NPM's open source. But the problem, I think the big thing standing in the way has been there are just too many different types of JavaScript formats for module dependencies, but I think Steel goes a long way to solving that problem. So the next thing this shows off, which I think is in a nice way, is custom HTML composition. I'm going to talk about real briefly why it's great, and then what I think we do at Bitovi and what this app demonstrates we do a little bit special to make HTML composition easier with custom elements. So I feel like there's a few people even at Bitovi who might remember the old days when to add functionality to a page, you'd have to create an element on the page, in this case the date picker element, and then in another script, somewhere totally different, you would have to initialize the functionality, like by calling a jQuery widget or something like that. We've got a lot of young people at Bitovi, so I don't know if you guys have seen these kind of days, but nowadays, instead you're always, every big library and framework provides the ability to use custom elements to not only define the place to add rich behavior, but to also initialize it at the same time. So JSX for React, Angular allows it just directly in the page, and then CanJS allows it in its stash and mustache templating languages. So what I think this is good for people at Bitovi too is we should always be striving to design our templates with Tom in mind. For anybody else who's watching this outside of Bitovi, Tom is Bitovi's UX director. We should be designing our templates with and our custom elements with kind of two goals. One is so that he could understand them, because Tom knows HTML, but he doesn't know JavaScript that well. Although he did release we all saw a PHP script the other day, which we were all very impressed by. We should design one so that he understands the page, but also we should try to design our components, our custom elements, so that he can rearrange them into rich behavior without having to need the help of a developer, right? So we want to make a rich ecosystem of widgets that he can assemble into, any behavior he chooses. So I think there's two elements that can provide. There's two things that we do, but the first one are creating two different types of elements that work well together to add rich behavior to a page when used together. And I think, though, that tag team of elements are, first type is elements that can load data. So we've added CanConnect, and CanConnect allows you to connect a connection to a tag element, and then you can load data directly from the template. And the second thing are composable widget elements. Bit tabs is an example of this, but also this bit series that Kyle worked on that allow you to kind of, by rearranging parent and child elements, you can create a rich behavior of for custom elements. So I'll show a quick demo of this in action. So here's a dummy analytics page that just shows a single restaurant's sales data across several days. The page for this looks like this. I am using my order model to find all orders that are for Slug Cheese Curd City. This is clearly a Wisconsin restaurant. And then what I want to do is take the value of the promise. So this essentially, you can think of the view model of order model as a promise. And I want to take the promise's value and export that into the surrounding template as Cheese Curd City. And then what this does is uses creates a bit series and a graph. So this is the series data, and it specifies that the series data is Cheese Curd Cities, which is a model list. Its total is the result of calling its totals function. All right, so just to show what the models look like for people at Bitovi, here's what the order model looks like. So I'm creating my own map, so the order map. So this just defines the behavior for an instance of an order object, you could think of it as. And you can see a order has a total, which is all of the items for the order summed up. Then I'm going to create a order list. So this defines the behavior of a list of orders, and this has that totals function that is just going to go through and create a mapping from each order to the order list. Basically, just return an array of each total for each order. Then I'm going to use CanConnect supermap, which is like a there's different kind of connections. This connection connects a map and a list to essentially every single thing CanConnect provides, which is why it's called supermap. So this creates a connection, and I want to hook up this connection to API orders. Here's the ID, the map that I want to create instances of, the list I want to create, like if I have a list of data, I want to create instances of this, and I have to give it a name so it knows what to store in local storage, and I have to provide any kind of special set logic comparison stuff, which I'll get into, is provided here on this compare object. So status, basically what I'm saying is status can be one of new, preparing, delivery, and delivered. And then just to show a little bit of the real-time connection, I can listen to when a order is created, pushed from the server, and then just call the order connections create instance. This is all I have to do to wire up a real-time connection. And we'll talk about how the live inserts and removals work. That's there. And then that tag behavior that I was eventually really just trying to get to, all I have to say is I want to connect the, by the way, this would look like CanConnect.tag if you were using everything from the CanJS namespace, but because I imported the tag from CanConnect tag, that's why I just write tag. I want to connect order model element in the page to an order connection. So there's a helper that just allows you to say, hey, make a custom element that can you do things to a certain connection. So once I've created my model and connected it to a custom element, that allows me to do this. And this is a proposed new syntax on any element, really, that will take something within the view model of that element and export it to the surrounding template. But let's say I wanted to add a different series data. I wanted to compare two different restaurants' data. I can do that with a little cut and paste because I don't want to type it all out. I can use my order model to now also load Poutine Palace's data, save it as Poutine Palace here, and then create a new bit series with Poutine Palace's totals. So with that, refresh my page, and I get now two line graphs.
So what's your order model tag? What's the view model for that?
It's the promise that this find all would return.
Couldn't we just put that within the tag, like the order model tag?
I don't know. Yes, yes. So you could actually nest if you wanted. You could do.
I found that like easier to follow, but I guess it.
But the problem is, how are you going to have which you're going to have to be very careful with your nesting, because you'd go like 2 levels up for this total, but then you would want to have to go 3 levels up if this outer order model was also wrapping bit graph.
Yeah, I just saw that. That's true. If you only have one, it's.
If you only have one, it's probably a little bit more obvious to just do. You know, you could actually write it like this then, because it would look up totals. Well, no, you would actually look it up. You would have to do value.totals. So it would look up the value of this promise and then get it. I don't know. I think that, at least for this example, I think it's easier just to write it out like this, because then things are nicely labeled. Any other questions? You could, just so everybody has you could do stuff like this too if you wanted Poutine Palace promise, and then you could do Poutine Palace promise dot value dot totals, and this would wait until the promise's value is resolved and then do totals. You could do stuff like that. Okay. So that's the first thing. I think it's my hope that these kind of custom, these kind of model layer tags combined with these composable Okay. So the next thing, which is I think pretty cool, which hopefully some projects are already kind of using, which was in 2.2, which is can import. So we can import, use can import to import dependencies directly from the template, from stash templates. And this way, this would be really nice too for hopefully like someone like Tom, that they can, or even for us, that if you want some behavior, well, you can put your import by the code that's actually using it. So if I wanted bit tabs, all I have to write is can import from bit tabs, and then I could just start using the tabs immediately in the page, which is really nice. I think we're the first people to really offer this too, which is pretty cool. So then the final thing is, hopefully some of you are familiar with the proposed web, what like creating a web component would look like if you wanted to do it within HTML. So the idea is that you could define the web components template, it could have a style tag, and then the actual template content, and then you, in a script tag, you define the behavior of its prototype and register that prototype behavior as a custom element. What Matthew has done is created a CAN component custom element that you can define like this. You can give it a tag, you can give it your styles as less, a template, a view model, and it looks like this. And I think we have a bigger example in here. Where is this in? Is this in history? No.
It's in
phone?
order phone, yeah.
Okay. So here's a component that validates that there's a phone number in an input element. So here we can have our style, we can have the template, and the view model defined. It's our hope that, you know, for a lot of our components, you should probably break them up into different different files. But for small ones, I actually think that this, at a certain point, is a little bit easier to look at, just because you can see, you know, especially if you can fit all of your code in one page. I think it's a little bit easier to look at this than if you were to put this in 3 different files: the view model, the template, and the style, if you've got something as lightweight as this. So I'm hoping that this becomes very useful for quick, lightweight components, especially as our templates become a lot more powerful. I could see this, and view models become a lot smaller. I could see this becoming a lot more valuable. By the way,
you can also there's a syntax you can say, like you say view model from equals, and you can put your view model in a different file, or you can put your template into any of these. You could put, like, if you have one that's really long, you could put that in a different file if you want to do that as well.
Yeah. So, and one other thing, everybody who is joining us, it's okay right now to be very critical of what we're doing. Yeah, this is a public video, but if one of you guys are like, this stuff is stupid, totally okay to voice those opinions right now and have the discussion out, because none of this stuff is finalized at this point. So, you know, now's a great time to get in ideas or things that you think need to be improved before it becomes too late. All right. Next thing I walk people through is how we make unit testable view models, and I'm going to kind of run through this real quick, but I think it's still valuable, the steps. We take our identifying values that represent the state of the view model, then write a test for the view model, write the view model, and then typically at the end, writing the template becomes very easy. For this example, I use the picking a restaurant view model in this page's behavior, where you could go to the restaurant's page, it would show its loading states, then you could pick a state, then it would show its loading the cities, you could pick a city, then you would see a list of restaurants. And then if you were to change the state, your city selection should be removed and a new list of cities should be loaded. So that's the behavior. The first thing, and this is actually, like, I'm being totally legitimate when I say the first thing I do when I'm ever personally building widgets is I sit down and identify all the properties that represent the state. I always do this when I'm building applications, and I do it almost exactly how I'm showing in these presentations. So I write a little curly braced object like this, and I just walk through all of the different properties, and I try to determine what values they should take on based upon the interface. So if I see that the state is loading some states, well, then I want states to probably be a promise that resolves to the list of states. Then when someone picks a state, well, I would decide, okay, what do I want? You know, maybe in some applications I might have like state ID, or I'll have, you know, maybe the state will be Illinois written out. But in this case, we just picked the basically the identifier that we're using to identify states, which is the abbreviation code for the state. So it's a string. Then cities is also loading, so we need it kind of to express a loading and loaded state. So promises are obviously ideal for that and should be resolved to a list of cities. Then our city is Chicago, and our restaurants, even though I'm not showing them loading, they do. I kind of just forgot, didn't want to put that in these slides because it would just get super redundant. Restaurants is going to be a list of restaurants. And then the next thing that I do is I kind of, in my head, identify the relationships between these different properties. Some of them actually are the state. Like, when I say state, I mean, like, you know, not state as in country, county, country kind of state. I mean, they actually represent the state of the user interface, like the state property does, as confusing as it is to use both those words. But cities is the dependent state property dependent on some other property in the state, right? So cities is like kind of a side effect of actually setting the state property. So I kind of work through that in my head and figure out what those relationships are. I'm not really diagramming them here, but sometimes I'll draw like arrows and identify which ones depend on other ones. Then the next thing, if I'm being good, I write a test for the view model. So the test setup, I'm going to not show through the slides. I'm just going to show through what it actually looks like. So this is restaurant. This test. So test setup, hopefully most people are familiar with seeing this already. I'm going to import my view model, but I'm going to call it restaurant list view model from my eventual list component. So I've got the restaurant list view model, I've got queue unit, and I've got fixtures. I'm clearing local storage mostly because I don't want my can connect to use anything in local storage. I want it to always hit the fixtures. I create my fake data with states, cities, and some fake restaurants. And then I'm going to wire up my fixtures to hit that fake data. So hopefully you guys have all seen this. One thing that's coming, I think that Matthew and I have talked about that'll be coming pretty soon, is a way of dependency injecting your own, like for instance, instead of hitting, like the only way of simulating the fake data is to use fixture to trap the AJAX requests with can fixture and send them to our fake data. Instead, we could provide our own version of the states model, right? To me, it'd be much cooler, and this is kind of getting off the rails here, if I could at some point do steal.clone or something similar, clone all of our dependencies, but what I want to do is provide my own app models state as something with a find all that is just going to return a can.inferred that resolves with this fake state data. This way, I don't have to like go all the kind of, you know, trick can model into making an AJAX request that I control. Instead, I can just totally control what can model looks like from the perspective of this restaurant list view model. We've got ideas there. That stuff doesn't, you know, this is kind of what might be next for Steal, is a way of doing that, dependency injecting different dependencies. make it so, yeah, you just don't have to go through so many layers to fake stuff. Anywho, then I just walk through testing my restaurant this view model. I make sure I get the states. It's a promise that resolves to the list of fake states that I got. Then I'm going to set the state to Cali Soda, and then I'm going to make sure that I get that the city's property is going to change. Make sure that I'm getting my fake cities back. Change the city, pick a city, then make sure I get the restaurants back correctly as a promise, as my fake data. And then finally, I'm going to change the state to a different state. I'm going to verify that the city value was removed, and then also that my restaurants were removed, and then I also got a new list of cities. So that's what a good solid test, I think, of the view model looks like. And then step 2 is I actually wrote the view model, which I will use the slides for this because they're a little bit easier to digest than just looking at code. Okay, so the next thing is I write the view model. This is using ES6 syntax. So essentially this makes a value function shorthand, which defines the initial value of states, which I would just want to get all states from my state model. Then state, I'm creating a setter with a define plugin that just has a side effect of removing the city attribute. Whenever state is set, it will always remove whatever selection for city there was. One thing that people might not know is that if set doesn't take any arguments, then you don't have to return anything, and it assumes this is totally just here for side effects. So you don't have to worry about, like, because this function is returning undefined, that state is always going to be set to undefined. If it doesn't take any arguments, you don't have to return anything then. Cities is going to depend on what state is set to. This is one of those dependent values in our view model. So I'm going to read the state. If there is a state, I'm going to use that state to get all cities for that state. Again, using ES syntax, this makes an object with a state property that is state in the current scope. Finally, city really doesn't have anything, just needs a null value to start. And then restaurants is going to look just like cities, except it's going to get the city and the state and use that to request. If there's both of them, use that to request a restaurant for that city and state combination. So then finally, with all of that, the template becomes really easy. We two-way bind. This is just the part of the template that's listing states. We two-way bind that select dropdown to the state, disable it while the states are loading, also show loading while the states are loading. If there is no state selected, we're going to write out choose a state, and then finally we're going to list through all of this. Once the promise of states is resolved, we're going to go through each state value and write them out. So that's what that looks like. Two-way routing, I'm not going to really talk about that. I wanted to talk about CanHref again, which was added. No, this is not in 2.2, but it will be in 2.3 for sure. This allows you to specify. Ilya did this, and this allows you to specify an href in an anchor, but using the properties you want to set in the CanRoute state. So in this case, if I want page to be restaurants and slug to be slug, CanHref will turn that anchor's href property to restaurants cheese city using the reverse routing rules of CanRoute. So because CanJS is reverse routing, which like two-way routing, and it can you go through the reverse routing algorithm. Essentially, this means that in any CanJS application, all you need to do is change your routes, and because your href is still setting the properties that it wants, the actual resulting href will just update itself automatically. So you don't have to ever go back into change your hrefs because you want to change your routing rules. In a CanJS application, you should be able to change your routing rules at any time, and the application should still work. Okay, so now the big one, or one of the big ones, start of the big cool things that we're doing, and with supermodels. So I think we've done a really good job of solving a wide variety of problems with either performance or real-time connections. And I'm going to kind of speed through this. So, and it all works with sets. So with set logic. So yes, set logic is just like Venn diagrams. Here's the kind of set like value. So like a I didn't actually give these in my presentation, but it's worth it, I think, for here with everybody at Bitovi. Two sets are equal, obviously. A and B are the same. If one set is a subset of another one, that means if A is a subset of B, that's what the subset thing looks like. Let's do that so as much room as possible. A subset is either the same as the other set or represents essentially fewer items, but those items are all inside the larger set. Proper subset, however, is always, it's not equal, but B contains every object in A. The set difference is everything in A that's not in B. The set intersection is everything in both A and B, and the set union is everything in both A and B. So with that, with sets, we can do a lot of interesting and awesome stuff with set algebra. And the reason is because, and the reason why I feel like it's a natural fit what we're doing is because whenever you request data to a server, you're always providing some information about the set that you want to retrieve, right? This set A object, which is the params I'm passing to API to-dos, really represents the set of data that we want. We want user ID 5 and completed true. So we want all items for user 5, all to-dos for user 5 that are completed. So if you have sets that are described like these objects, you can have the ability to compare them to other sets. In this case, set B is all to-dos for user 5 that are completed and critical. If you can compare set A and B and know that set B is a subset of set A, well, you know if you've already loaded set A's data, you don't have to, for example, load set B's data if you can compare these two objects. So we created a library called CanSet that is able to compare objects that look like this and let you know if they're let you know if one's a subset of another, if it's an intersection, union, that difference, all those kind of methods. Set can help you figure out. Set can also handle more complex set algebra. So here you can create your own set algebra where I'm specifying, for instance, that the start and end property represents a range. The status property has two enumerable options, which is either new or delivered. And the completed property is a Boolean that can either be true or false. And if you specify your own algebra, well, you can use it to kind of compare things like this, like that the start, a set that is from 0 to 50 is a subset of a set that is from 0 to 100. So let's see some of the performance things you can do with that information. So if we went to a page that was loading we want to make two independent widgets, one that was loading all completed to-dos and another that was loading all incomplete to-dos. Those would want to make two for complete true, the other for complete false. But instead, we can use set logic to take the union of those two sets, because we know that this would be a binary property, a Boolean property, complete. We could then instead just request all data from the server. Right? So this is a way to combine requests, is by taking the union of all request sets that are going out. Let's say we went on a page that had loaded all completed to-dos, and then we wanted, so it loaded all completed to-dos from the server, but then we went to a different page, we navigated to a different page that was loading all to-dos. Well, this would try to request all to-dos with a request like this. However, we could compare what's being requested against the set of data that we've already loaded and get the set difference and only load what needs to be loaded. And then finally, this works amazingly well for real-time server-side events. So let's say the server was going to push to this page that's showing both completed and incomplete to-dos. It's going to push an incomplete to-do. Say, hey, a new to-do is created. Here's what that to-do looks like. We know the sets of our complete to-do and our incomplete to-do. We can actually compare new to-do to each set and see if it's a subset of this set data. In this case, the incomplete, the new to-do is a subset of the incomplete because they both have complete false. So because that's true, we could know, hey, push this to-do into this list. Just by comparing, by associating, basically what we do in CanJS and CanConnect is every model or every list that's produced by CanConnect keeps the information for what set it belongs to, and then we can just look through all those sets and figure out what, when an update or create happens, to either remove or insert the new data or the updated data into that appropriate list. So PlaceMyOrder has automatic live updates and an inline cache. It can combine requests and do fall-through caching. I'm going to describe how these things all work with CanSet. So let's talk about how the inline cache works first, and we'll kind of circle back probably a little bit to this at the end of this talk. So the PlaceMyOrder application is server-side rendered, and when that request comes in and the response goes out, it writes a little inline cache variable in the page with all of the requests that the server knows the client is going to make. So if we're on the order history page, I'm just going to show the order history page real quick again. If we're on this page, which is trying to show new orders, preparing orders, in delivery, delivered orders, the server is going to know that that's what's trying to be shown and inline that data in the page response. And then the page is going to be drawn because we're doing server-side rendering. So no JavaScript is even run, but we see the page. But what's going to happen is then JavaScript is going to become alive. All this page order history is mostly a template, and I'll just show what that looks like. All it is a template that's using the order model to find all status that are new, and then it's just going through and listing each one. And it's doing the same thing for all the orders that are being prepared, or are being delivered, and are delivered. So when the template is rendered, so again, the page just looks fully rendered before any JavaScript runs. Then JavaScript starts running and wants to render the template. Rendering the template is going to make the AJAX requests for this data. That's going to go through Supermodel, and Supermodel is going to say, hey, inline cached, can you satisfy these requests? Yes, you can. I'm going to return that data, which is just going to essentially re-render the page just back to how it looks, but now having the actual data of the page. And then finally, it's going to save the inline cache data into local storage for any future requests. And it should be able to combine these 4 requests, because they represent all the different possible values of status, into a single. It knows it essentially has all the data for every order, because it's essentially even though it's gotten 4 different versions of it, it knows it can combine all of these into the like I want to call that like the set of everything. There is a special name, mathematical name for it, but it escapes me at right time, like the universal set. So a fall-through cache works like this. So the person now has navigated to order history using push state. So the server is not going to serve up the page for that. Instead, we're going to use JavaScript to get the data from the server, because we already have JavaScript running and it knows everything that it needs to do. So in this case, it's going to make a find all, 4 different find all requests to Supermodel. Supermodel is going to combine that into a single request for all data, hit local storage, and use that as the response, and break that response from local storage up into the 4 different responses, 1 for each of these requests, and then use that to update the page. Now, the fall-through caching means that once it's done that, it's then going to also make an AJAX request to the server in the background. And it's going to make a single AJAX request, because again, it was able to combine these 4 requests into 1 request, and then use that to update the it's going to use the new data to make any changes to these lists. So let's say we had some new data coming in when we requested the server. Well, there was a new item. Supermodel would see that, hey, this new data has a different item, and update the can model list that was used to render new by inserting the new item returned by the server. So the user will see like an item, but then automatically they'll see a new item when the server response comes in, without a programmer having to do anything to add that behavior. Finally, how real-time works is, I forgot to mention, and then finally when the server response that finishes updating the lit elements in the page, it also updates the cache with any new data. Finally, the real-time is going to send one of those, you already saw how we hooked up real-time events to a connection to our supermodel, which I really should call connection now, because that's really what this is. But the server is going to push a updated event from which changes a order history from new to preparing. And what Supermodel is going to do is go through, take that item and go through and see, does it belong in any of these lists, or is it in this list and doesn't belong there anymore? So what it could see, if the status was changing of an item from new to preparing, it'd say, hey, you were in new, but you don't belong there anymore. We're going to shift you to preparing. So that's exactly what will happen. Again, and then it'll save that data to local storage. And again, all of this rich real-time behavior happens without the developer having to do anything to set up. You just make a find all request in the template, and everything else happens underneath the hood, which is like, I don't know, feels like magic to me. So hopefully, I don't know how many of you guys are already using live reload, but it's awesome. I'm just going to quickly show it off again. So let me do this in place my order. So here I've got my place my order. I'm going to, well, first we can just see the difference in time, especially if you're doing all the transpiling in the browser, the time it takes to refresh the page. But first I'm going to set up my live reload server. What is it again, Matthew?
I think it's npm run live reload, maybe.
Thank you. Okay. So let's do a quick comparison of how long it takes to reload the page with a normal refresh. Okay, it just took 3.77 seconds, which is a long time to wait from when you make a change to hit refresh and actually see your pages, or see your changes. The live reload stuff can make it almost instantaneous, like sub-second. So if I go to this page, which is order history, open up this and change this to orange, you can see how fast it will change. I don't know if you guys can tell, but it's pretty much instantaneous. So we have live reload, and this is really great because it's all about human attention span. So anything that takes over a second, humans will immediately start, being more likely to think of checking their email, responding to a tweet, checking Reddit, that kind of thing. But because live reload typically is sub-second, it can keep you more focused on the actual problem you're trying to solve. So it's pretty nice. Let's talk about how it works. So normally when you request a page, what has to happen is, use something like AMD to load all the modules for your page. What require.js will do and Steal will do is it'll first request the main module for your page. And then it will load all of that module's dependencies. If any of those dependencies can be executed because they don't have dependencies themselves, it will. But it will then go and get those dependencies until it gets all of the dependencies and the whole dependency graph, and then it executes every module. Until history, typically your main module is executed, which in most applications is what results in drawing out the page. How live reload works is that instead of redoing this whole process every time, when history less changes, it essentially is going to mark that as needing to be re-executed, but then also delete the content for history less. And then it's going to mark any of its parent modules as needing to be re-executed. But it's not going to delete their content because the file still looks the same. It's just going to mark them as needing to be re-executed. So that when history less is re-downloaded, that's the only file we need to re-download. We re-execute history less and then re-execute any of its parent modules. And then the page changes. So what's awesome about this is that if you notice, we not only don't have to re-download jQuery and CanJS, we don't even re-execute them. You're still using the same CanJS instance of CanJS library essentially that you were using before. Now, the caveat to all of this, which I did not mention in the presentation, is that you have to beware of stateful modules. A module that changes the state of the page, like creates an element or does anything that leaves some kind of side effect, those can become tricky to deal with in this scenario. But there's hooks that you can use that Steal provides that you can deal with these problems. if you encounter stuff like this. So one of the next things I think also Matthew and I have talked about is we really want to make sure that tests can rerun automatically, but we're going to have to figure out a way of doing that. So live reload doesn't work great for tests, but that's what I really want. That you just change your file, you can keep your test page up, and then it just re-executes maybe the test page that you really need to, and not all of your tests. That would be fantastic. Okay, the next thing is Steal, how it does smart progressive loading. And hopefully everybody here is familiar with in general Steal's bundling algorithm, but it probably doesn't hurt to go over it again, especially if you guys have any questions about it. Oh, that is not what I want to show. How do I switch monitors? Okay, can you guys see my presentation?
Yep.
Okay. So I'm going to talk about how Steal does its bundling with a multi-page statically loaded site. So not a progressively loaded site, but progressively loaded sites and multi-page statically loaded sites more or less work the same way. I just think it's easier to understand the benefits for statically loaded first. And then if you guys have questions on how it applies to progressively loaded, I can talk through. Well, let's say here's my 4 different pages: home, restaurants, order, and order history. And they each have the dependencies listed underneath them. The first thing most people do when they're building a site like this is they will just put every... am I loading the wrong one here? Hold on. I might have loaded the wrong presentation. It did. 1 second. Yes, I did. Hold on. Sorry about this. This is me. This is gotta be it. Yeah, okay, this is the right one. Okay, so the first thing that people do when they're building a site like this, they might take all of every single page and build it into its own production file, right? A single production file for everything the page needs. Well, the problem with this is you're not benefiting from caching at all, because title CSS and jQuery were in every single page, and CanJS was used in 3 of the 4 pages. So the next to pull out those modules and build them into a separate bundle, and then have homepage, restaurants, order, and history load that bundle, right, to experience your caching. Now, this is okay, but it becomes harder when, like, well, maybe CanJS, now history is loading CanJS, and it really doesn't need to. Or you start having lots and lots of things you want in this core bundle, well, maybe we should pull CanJS out and have homepage, restaurants, order load just that. How do you decide what belongs in which bundle without a lot of experimentation? It can be very, very tricky to figure out. So don't figure it out. Have Steal do it for you. So Steal has a bundling algorithm that I think pretty much solves this, or gets as close to you could without actually analyzing like how users actually use a site. I think this gets as close to making a perfect build as possible. So here's how it works. This is the dependency graph of all the different mains of different pages we want to load. The first thing it does is it figures out what is the most shared by all of the different mains, and that can be grouped, and groups those things together into their own bundle. So jQuery and title CSS are used by everything, so it's going to group those things. And then you can see carousel, cart, and CanJS are used by homepage and restaurants, so it'll group those things. It'll make slider into a bundle and color into a bundle, and history and grid will be bundled together, and then it'll make bundles for the mains. For just what's in homepage, restaurants, and order will each be in a bundle. Now, the dependency graph now shifts to something like this, right? Where you're loading bundles that have a bunch of modules in them. So homepage to load needs to load the HO plus R bundle plus the HO plus R plus O plus high bundle, Horo high bundle. And restaurants needs to load these things, and order needs to load these two, all of these. Now the problem, what you might see, is that restaurants sure has to load a lot of modules. It has to load 5 different scripts potentially to load its page. And if restaurants was a really important page, this could be not so good. So the next pass of the bundling algorithm allows it to combine scripts, combine bundles, so that no page has to load more than a certain amount of bundles. One thing to point out right here is that everything is perfectly cached right now. So if the user went from homepage to restaurants, the nice thing is that they would only have to load restaurants, R plus O, and R plus high, because presumably HO plus R and Horo high would already be cached. But we can still do better because we can reduce the amount of scripts. So what we'll start doing is trying to combine all of these bundles to figure out which one adds the least amount of waste to the overall loading of all the different pages. So maybe it'll combine HO plus R plus O. And what that will do is mean that homepage now has to load slider when it didn't have to before. So it has to load 2 kilobytes because that's how big sliders is minified. And then order, though, is going to now have to load carousel, cart, and CanJS when it did not have to do that anymore. So it's going to have to load 30 kilobytes of extra waste. So this adds 32 kilobytes of extra waste to be able to get restaurants now only loading 4 scripts instead of 5. Well, that might not be ideal, so it'll try other combinations. In this case, it might try to combine R plus O and R plus high, and this might only add 5 kilobytes to order and 2 kilobytes to history, so only 7 kilobytes of waste. So it'll combine these scripts so that restaurants not only is loading 4 scripts, you still have perfect caching between pages. It's just order and history are loading a little tiny bit more than they probably had to. But, you know, likely we do the minimum waste because a lot of times, I'm not showing it here, a lot of times R plus O might have things that history might have to already be loading R plus O, and order might already have to be loading R plus high. It's just there's like one file in each one that the other doesn't have to load. So a lot of times when you combine these scripts in this way, it's not even like you're combining 2 independent bundles. A lot of times you're just like there's one module in one and one module in the other that aren't used. So when you combine, it's actually very minimal waste you tend to get when you start combining scripts in this way. Okay, so that's Steal's build system. And then the other thing that we do now that's really cool is we can use can import to progressively load modules. So I think Matthew will talk a little bit. We can talk about a little bit how the bootstrapping of the application works in general. But this is what our main module now for place my order is a template file. And this is kind of what we talked about in December for those who were there. To progressively, we check if when the page is home, we progressively load the home module, and then once it's resolved, we write out the home component. And these imports are automatically set as the bundles to build in this progressively loaded system. So it'll automatically package app home home and let's see, app restaurant list and do that steal bundling algorithm with these as kind of bundle endpoints to load, which is pretty cool. You don't have to do anything. So yeah, the final part is server-side rendering, which is there to get rid of these kind of things. Spinners while your JavaScript is loading. So Matthew, you want to take over and kind of show?
Yeah. Absolutely. Forget how to share my screen. Okay, here we go. So one thing you just said, one of the problems. So the reason why I'm talking about this now. Get out of this is because when we were developing this app, we kind of ran into some problems. Oh no, this is not good. Yeah, we ran into some problems where you're loading your main, you're loading a stash template as your main module, but you still want to have, you still need a template for the overall HTML page. So we had this thing called layout.stash, and basically all it did was we would render the main template and then kind of stick it inside of here. So I think what we might move to doing now is we'll just have the entire HTML as your main. So this has HTML. It has a head section. You can have your title can be dynamically changed if you want it to be. And then you just have everything inside of the body. This is kind of what the main used to be. It's just the body section. So how this actually works, and I'll just show you. Oops. You can just curl the site and you get back a full HTML page. And if you'll notice, what Justin was showing before is that we have these dynamic can imports. So here we've dynamically imported PMO home home, and then it's actually waited for that import to finish, and then we're using the PMO home component. So what's actually happening here, how this actually works, is that every time you import something, we keep that around as the state of the overall request. And so you might be importing several things. You could possibly have can imports nested inside each other, or you could be doing AJAX requests. But any type of asynchronous thing you do, we keep track of those inside of the request, and we wait for all of those to finish. And when everything is finished, we have the fully rendered template, and that's what we respond with. So the code for this, I've created a new module called Steal Server-Side Render. It's probably be renamed to something else, perhaps Done Server-Side Rendering, because this is more of a Done.js kind of thing. So it's a new module that you can import. You give it a options object, which is if you've ever set up Steal Tools build, it's the same thing. This is basically what we call the system object. It contains the path to your config, which in our case is the package JSON, and the path to your main, which is in this app, it will be this layout.stash. And then to use it, we're using Express here. So usually in Express, and this is one of the cool things about doing server-side rendering, usually in Express you have to define all your routes. So you'd have to say use orders, and then a function with a rec and a response, and then you'd have to render just orders. Well, we don't need to do that because we've already defined all of our routes in a routes file. Let me show you here. We have routes.js. This is the client code where we're defining all of our routes. And this module is actually going to use canRoute. It's going to use, if you ever use canRoute dparam, you basically pass it a path, which this might be, this might be orders. It's gonna take that and find out that the page is orders, and it's gonna pass that into the render function. And then, like I said, it waits for all of the imports to finish, and then it renders it to HTML. So one of the hard problems that I've been working on the last couple of days is there's side effects associated with loading the page. Like if you go to the orders page, you're rendering a template, but at the same time you're like importing CSS is the best example of this. But that kind of happens as a side effect. The CSS plugin in Steal just inserts that into the head. So in order to know about this, Steal server-side render does a trace of the entire import process. So it knows that because you imported PMO order, that resulted in a new style being inserted into the page, and it keeps track of all of that so that whenever there's a request for orders, it knows, hey, I have to give the order style as well. So along with Steal server-side render, it gives you like a nice little helper asset, so you can have a plugin can register itself as being a provider for a type of asset. So the CSS plugin is going to register itself as a provider for CSS, and what it will do is it will actually, I can show you when it renders. Oh, yep, here it is. It rendered this particular less file. Actually, you scroll to the top. I can't scroll to the top. But anyways, it's gonna know all the different styles that were inserted because of this. And the same thing, it works the same way for our inline cache, which is the thing that Justin showed you before. So it's pretty nice API. I'm still working on the kinks a little bit, but this is more or less what it's gonna look like. So you'll be able to server-side render your entire code, and then when you launch your application, it's gonna again render the template just like it did on the server, and insert that into it's going to insert the head section into the head and the body section into the body. But there will be no flash. You actually won't be able to tell that it happens. I think that's about it.
Asset CSS, does that work for production?
Yes, it's exactly the same.
Okay, so this is actually a problem that we've probably never solved, I'm guessing.
Yeah, it's going to eliminate, you won't have to do this anymore, because this doesn't make sense in the server-side context, because you're going to be inserting a bunch of different bundles, so we're just going to kind of figure that out. Have a method to do that. But yes, so in production, you'll have, if you go to the orders page, it's going to insert a link tag to the main.css, but it's also going to insert a link tag to orders.css.
Yeah. And then any other potential bundles that have CSS.
Right.
Yeah.
Any particular bundles just for that particular page.
Yeah, that's awesome. Does that make sense to any you guys? I gotta imagine that this doesn't make sense. And then,
yeah, if
you guys have questions, now's a really good time to ask them, because I can see very shortly this is what we're gonna, this kind of technology is what we're gonna start really pushing hard for in our apps.
Is can tag something new in 2.3, or does that already exist?
Oh, that's probably not going to be like that. So the problem that we are trying to solve there is, if you saw from Justin's slide, you have to do, because the view model for can import is a promise, so you have to say is resolved. Yeah. It becomes very cluttered. So can tag is a way to say we're going to hand over the rendering for this component to another tag, and that tag can have that logic inside of it. So the PMO loading component waits for it to be resolved before it actually renders the sub-template.
Gotcha.
But to answer, yes, we will, but maybe not in this form. Well, something like that.
Yeah, I mean, just to elaborate a little bit more on, like, it's kind of, we actually, while doing this, discovered a problem with the multi-build that I'm surprised we never noticed before, which was that, well, if you were using the multi-build before and trying to inline the production link tag references, right, which is pretty common practice, that, instead of using Steal to load CSS, you'll write your CSS tags directly in the page. That was not actually working like the way it needed to, so that you would in fact load all of the CSS for your page. So this stuff, that part of the stuff that Matthew's doing, will solve that, and it actually will be quite useful for, I think, even if you were doing not server-side rendering, it probably wouldn't hurt to have similar helpers that can write out the production CSS so that it can be inlined correctly for every page. Because different pages will have different sets of CSS that they need to add for bundling and for caching. I don't know if that makes sense.
Yeah.
Cool.
Yeah, I'm surprised no one's noticed that before.
Yeah. I don't think we're using it, but I'm surprised Sam's didn't notice it, actually. That's what I'm most surprised. But maybe you guys aren't bundling CSS? I don't know.
We can talk about that if you want to.
Yeah. No, I guess not, because this is public, yeah. So the one thing I wanted to point out about the server-side rendering is what makes it special and a little bit more complex. So there's a lot of different ways of doing server-side rendering. A common way might be to create a new JS DOM in a document in a new context. What I mean by new node context is like it has its own copy of array and set timeout and all. It's basically like a new window. It's almost like you're popping open a new iframe, and then you render your page in there. That works nice because when you have your own context, you're not really worried about side effects. But you've got to create a new context for every time you render the page, or you have to do complex stuff like keeping a context pool and figuring out which ones are open or not and rendering there. What we're doing is kind of like what the similar thing that like React would do, which is to run in a single context virtual DOM, which means that every single page request runs in just a single node context. So what that means is that like the same model AJAX request that goes out, it's kind of happening like for one page response. For when we're trying to generate the HTML for one page response, and we might make an AJAX request that's going to load data and then insert that into a document. That's happening in kind of the same place that another page request might happen using the same model. So things like knowing when to finish the page, like when all requests have finished for the page, you can't do what you would really want to do, which is just wait for all model requests to finish and then take whatever the document looks like and add that to the page. Well, you can't because you're in a single context. But a single context gives you mad speed. The other thing, we're using a virtual DOM, which is a very lightweight DOM. We're using simple DOM, some changes to that that makes it so you can render itself much more quickly than it can with normal elements. And so you don't actually have to load a DOM. And then the challenge, which I kind of got to, which relates to single context, is that everything is related to the render lifecycle. So instead of being able to maybe hook into model AJAX requests and know when all AJAX requests have completed and render the page, instead, oh, this is not what I want to show. I want to show this. Instead, what you need to do is we're adding a root attribute that you can access the top-level view model of any rendered stash template. So this is the data that the stash template is rendered with. So you can access that in components, and then I'm going to get the, like for instance, if I wanted to make sure states, I'm going to wait for all states to be rendered before I draw out the page response, and I'm going to make sure that all and I'm going to actually put this state's data in the inline cache. If I want to do that, you have to connect everything through the page, like the top view model. So I'll get the top view model, and I'm going to add that promise to the page data that I wanted to render. So this will have the two effects of waiting for this to resolve before it renders, takes the final output of the page and uses that for the response content, and then also taking this and putting this data in the inline cache. So that's what this is. We're going to have to do this kind of stuff in our components and other places where if you want the page to wait for this to happen before it's rendered on the server, you have to add to page data, and you can also include this data as part of the inline cache. So it's a little, so with this, it kind of, I feel like there's, these are the different techniques to get server-side rendering. I think in terms of maintainability versus speed that you can get. Yeah, if you duplicate all your code and write your own server-side code completely from scratch, well, you can get crazy fast performance, I'm sure, but not great maintainability. A headless browser you could use. It's great for maintainability because if you're creating a new context every time and you don't have to worry about side effects or page life cycles, your code can probably just run straight in the headless browser without any hassle. But it's not that fast. And then the single context virtual DOM, which is we're using, I think is a really good mix of both maintainability, because you just have to add a few places where you want to wait for data and connect that to the page rendering lifecycle, but it's much faster than a headless browser. So I think it's a good mix of both. These can't really be used for dynamic sites, where on every page request you might need to do a render. You can't really use this technique, but you can use single context virtual DOMs. So that's it. Any questions? There should be a bunch, I would hope.
Back on that last slide, just before this one, where you had the at root, is that counting like when you do partials? Partials are just considered part of the template they're pulled into?
Partials can be made, because it's part of the template, if it does need to be an AJAX request for a partial, which there aren't. Partials are synchronous anyways. So partials should work, or if they won't at some point, they can easily be made to work. You really only need to do this for data that isn't, like order model does this itself, right, where you're using the, if you're doing,
Order model tag does, you mean?
yeah, if you're doing this kind of stuff, the order model tag adds this data to the page lifecycle anyways, so you don't have to do it. You only have to do it in cases where you're pretty much doing your find all yourself in JavaScript code. Well, you need to connect that. You need to basically pass that to the root model.
Don't you have to give this a name though? Page data, and then give it a name to add the promise?
Well, because it can connect.
Oh, it kind of knows what to
have its own state on it. So
Yeah.
it should be, even if you do right now, David, you're right. Right now, I think our example, you do have to include it. You shouldn't have to, by the time we get all of this working, because it should be able to get the set from the list internal.
I have a question.
Mm-hmm.
So how does the set algebra work with pagination and stuff like that? So if you have a first page of all items that doesn't have any like completed items in that list, only the uncompleted, how will it know that it doesn't have to load some new items on the next page or something like that? Or is that problem not solved?
So it's not totally solved yet. So there is a count method on that you can implement in your helpers. So like the set algebra. Where's that example? You can provide count information to CanSet, and like there's an actual algebra.count where it should give you the total number of items in a range. Although some stuff like your example, I'm not sure exactly what it was. There are some places where you can't actually know if this data belongs in here or not. And in that, then you'll have to add either special comparison logic coupled with additional data. Like you can create your own comparators that do whatever you want, and maybe your server is going to have to send back like, well, there are 20 items when the page loads. There are 1,000 items in these sets, and with that information, then you should be able to figure out whatever your. I don't know exactly what your use case. If you could describe it again for me, I could probably.
So if you have like a list of all to-dos, but you only have in that list, because of the ordering, only the non-completed to-dos.
You mean the sorting? So you've got
sorting. So it's sorted by date, right?
But wait, what did you request? What did the page request? It requested a sorted list of all to-dos.
Yeah, and first then you get 10 to-dos back.
Yeah,
and
how is it sorted? It's sorted by completeness?
No, by date. Creation date, for instance.
Okay, so then it would check the completion date of the new item compared to the first and last item in the existing set, and then be able to decide if that item belongs in the set or not.
Okay, but what if you want to go to a next page, which is like a completed to-dos page?
But
could not do a subset of that existing list, because although there are completed to-dos on the server side, there are none in the list that you requested. So would it know to request?
No, it would know, because it wouldn't be able to say that you've already have a superset of the data. It only
finds only one in that list, like it's 9 uncompleted and 1 completed item. Would it make a request for the 9 additional items or not?
No, it would make a request for all. I think in the example that you have to describe your example a little bit better to me. Like, if you want to write out in the sets definitively in the chat that you're requesting, I could probably make a little bit more sense of what you're asking. But it can only do what's possible through set mathematics. So there are some limitations. Like if I loaded from 0 to 100 a bunch of items, but then I wanted to load all that are completed, I can't make any comparisons between those sets.
Okay, that is the question.
It'll just request all completed, unless I've loaded unless it knows that I've loaded every single item, I've loaded the range of all items, then it could actually know I've got all items, so I can definitively decide I have all completed.
Okay, that makes sense.
Yeah, it's not omnipotent. It only works with the kind of like ranges that you could actually somehow compare.
Okay, great. Thanks.
Yeah, no problem. Any other questions? Comments, concerns?
Matthew and I started talking about it. We kind of need can route to know when there is a 404, because you don't want to send the rendered page every time, even if it hits a page that you don't know.
Yeah, I think that's been requested already.
Sorry?
That's been requested. That's like an issue in CanJS already, to like be able to have an event or something that gets kicked off when a route is not.
Yeah, and then also the case being able to define, like for a route, we define a page property, right? Be able to define, well, the page property only matches if it's like restaurants and order. For example, in order to be able to say, okay, well, you hit a page that matches the route, but it doesn't exist to be able.
Well, then you need to write your routes differently. You need to write your routes so that you actually enumerate the way you do it right now.
That might actually be what we should do in the place my order.
That's something we talked about the getting. I talked about the getting started team yesterday, is if that's worth it or not. And we kind of said that it wasn't, but I do maybe for the bigger app it becomes worth it showing that, because that is one of the biggest issues people have, is like understanding that you're working under the constraints of the reverse routing algorithm. all that implies. So, cool. Anything else? Hopefully you guys are excited about this, because I think, especially the server-side rendering and the Can Connect stuff, I think will really open the door to CanJS as being like a premier library for a certain set of applications, especially real-time ones. I think it'll make it super attractive. And those are kind of the fun apps to work on anyways. I'm pretty pumped about that. And the server-side rendering, too, I think can make us more appealing to consumer-type applications, because a lot of times what we've traditionally done are, internal big applications where SEO is not important at all. And I think this will let us go after some of those other kind of apps that are fun to work on. Cool. All right. Well, hopefully you guys learned something, and we will have a good weekend. All right. See you guys later.
Good. Thanks.
Bye.
Thanks for having us.
Yeah.